Yeah, database was no. We talked about whoever designed the UI for mobile view for Blackboard. Can we talk about this?
Yeah, no.
I can't even scroll. I feel like the bare minimum for being able to like design a website for like a real life product that people pay real life money for should be the ability to make it mobile friendly. That should be like one of the bare minimum requirements. No, the bare minimum is making it to work on a computer. Then you do mobile, and then that's like your bare cutoff. It's like you need to be able to do those two things if you're gonna develop for a company that sells their product. Am I wrong?
The PC pushes and just taking our data and just pushing it. It's just like having everything in this plotting to see how much variance it has. I mean, to be frank, it's just like, you're just seeing that after everything gets done, like all transformations, which data has the largest difference. That's what I thought. That's pretty easy. I mean, I think it's here, slightly dangling.
Slightly.
On registrations tomorrow.
Yeah, we have to wake up at 6 a.m.
We have to like wake up at
5:45.
Break it out and do it.
Wait, why?
It's quicker to do it. Yeah, like I messed up my classes. Like last semester this semester I wanted to take data mining but couldn't take it.
Interesting.
I think it's because it's so faster. Or maybe because it's hardwired into it. That's also there.
Yeah.
So your request actually reaches faster than someone on a laptop.
But I don't have like an Ethernet, so it's have to be Wi-Fi.
Yeah, I mean, but still, being on the ASU Wi-Fi is different than being on Wi-Fi. It travels.
Do I book you enough to get up at 5 a.m.?
You should. Because like I didn't get too lost in the last time. Trying to. Oh my god. Wait, is it any easier? Preferably because it's faster. Nice. You just got like the basics of communication. I feel like this faster just because.
Second floor at 5:45 a.m.
Sorry. Yes.
If you give me your phone number, I'll call you until you wake up.
I should wake up. I should like star 6, 7. I did that. Like all of my roommate.
Welcome to middle school. You made it, and I'm proud of you. I don't trust that number. That's a weird number. I would accept it. It says Georgia. I'm like, I'm already calling you from Georgia. So I'm
Please.
Por favor, queremos que haya
Okay. So let's get started today. So you get your midterm scores today. And project is due Friday? No. The thing is, and this is a bit serious. So the midterm went well for a lot of people. But the thing is, there is a rampant cheating. Why? Why is there cheating? I thought you were grown-ups. Why is there rampant cheating? That's not good. I mean, it's one thing to write wrong equations and get wrong answers. But that's a totally different thing to write the right equation, write the wrong equation and get the right answers. How can you write wrong equations and get right answers? Then figuring out the right answer without any explanation. And that too, like to the point of third place of decimal. Then word for word matching of 2 or 3 people. It's not good. And actually I have been looking at this for maybe the last 3 years. So people who are maybe trying to graduate this semester, they have been doing it for the last 3 years. What is happening? Is this the norm? That's what your seniors tell you to do? So this time I have decided I have to report. There are about 20 people, I have to report all of them to ASU. I don't care whether you cheated from somebody else or somebody else cheated from you, I don't care. I am going to report everybody. And you deal with it. This is not good. I'm very upset about this because it's a lot of them. It's more than 10% of the class. That's not good. 1 or 2 people I can understand, but more than 10% of the class? That's bad. There's something wrong with you. And not the rest of the 90%. The 90% did good. They are good. But what about those 20-30 people? 20-30 people is a lot, although the class is big. But 10% is a lot of people. So if you are not cheating, tell your friends not to do this. And they will get reported for sure. This time. This is not good. I am thinking even of getting rid of exams. Maybe do personal interviews. One-on-one interviews of people. And I will be grading based on that. So I don't know, it will increase a lot of workload on me because I don't want to do that. I have other better things to do. But this is, I am losing confidence on exams. It's not good. You have to either, if you are not doing it, if you are doing it, you have to stop. If you are not doing it, you have to tell your friends to stop. But this is not good culture. And I have been trying to be accommodating. I am extending deadlines of assignments and all that so that you can study for your exams and maybe have an easier course. But that doesn't mean you will take advantage like this. And specifically we told you not to cheat. And I also gave you a cheat sheet. You could have cheated on that. But instead you chose to use your friends as cheat sheet. That's not good. So now from now on there are I won't budge on any of the requirements. When I say assignment is due, that's the date when it's due. I don't care whether you finish it or not. That's not good. You are taking advantage. even if the majority is not, but a lot of you are. So either tell your friends to be straight or face the consequences. Does it happen in every class? People who are not cheating themselves, can you tell me whether you find cheating in every class, or is it just my class? Anybody? Do you see it in every class? Nobody is seeing. Anyway, let's drop that issue for now. Okay, so there was a question by one student that in assignment 2, I have said that okay, plot the eigenvectors, right? Plot the eigenvectors. But the problem is the eigenvectors are multidimensional. How do you plot them? Say there will be more than 10 dimensions, right? So how will you plot the eigenvector and see? Can you hear? No problems. I don't think the mic is working. Is it? Okay. So it's multidimensional. So how do you figure out? How do you plot? So there are two ways. One thing is that you can take two at a time. So first dimension C1, C2, and just show the direction. Right? Or you can do another thing. You can do what is called a spider plot. What is spider plot? Spider plot is a way to represent multiple dimensions on pen and paper. So what you do is you take this, and let's say you have 5 dimensions, and you have 360 degrees to plot 5 dimensions. Right? So what are the angles? So you can equally space out the angles. Right? So what you can do is 360 by 5 is how much? What? 72? Yeah, so 72? Okay, 72 degrees. So you take 72 degrees and draw lines like this. Right? So you drew 5 lines like this. Then each of these lines are one dimension. Is one dimension. So x1, x2, x3, x4, x5. Right? And then on each axis you plot the values, the coefficients. So then what you have is that okay, x1 is this for one eigenvector, x1 will have this value, then x2 has this value, x3 has this one, x4 might have this, then x5 has this. Then how do you represent it? You go from 1 to 2 and just connect them. Okay? So that is one eigenvector. Then you can get another eigenvector like this. Right? So then again you connect this. This is another eigenvector. So it looks like a spider. If you make a lot of them, it looks like a spider. Right? So that is the spider plot. So you can use the spider plot to do your eigenvalue. Now I would be assigning the third assignment. So third assignment, I'll maybe upload it today, and then you can start working on it in parallel with your assignment 2. So in the third assignment, just to give a look ahead, what you are supposed to do is, you are supposed to take each class, each gesture, there are 10 gestures, right? So you are supposed to take each gesture, and you are supposed to explore different types of machine learning algorithms. What types we'll see, whatever we have learned, right? Different types of machine learning algorithm to figure out whether that entire data set that you work with, whether that is that gesture or not. So basically you will have 10 different machines, 10 machines, or 10 evaluations you will do. So maybe fix 3 machines, say decision tree, SVM, and neural network. Let's say these are the 3 machines, right? Now on these 3 machines, what you do is take one gesture, say about, and you divide the entire set of data set into gestures that are about and gestures that are not about. Right? So ignore the other classes. The other classes, combine them together and make it not about. Right? So now you develop a machine that will test whether it is about or it's not about. Right? Then you do it for the other gestures also. So can or not can. Right? So you do this for the 10 gestures, and that is it. So in this case, you will do this in 2 settings. Maybe we can do it in 2 separate assignments. So assignment 3 and assignment 4, let's say. So assignment 3 will be in user dependent mode. So user dependent mode means you will further divide the data set with respect to users. So when you are looking for about gesture classification, instead of making a single model for all users, what you will make is a different model for different users. So it depends upon what data you use for training and what data you use for testing, right? So for each person, you have 20 about gestures, right? 20 times? 20 times they have done about. Now you have 20 multiplied by 10, so 180 other gestures. So what you do is, from about gesture, you take 10 instances, use it for training. And from the not about gesture, you take 90 instances, use it for training. And then when you test with the next of the 10 instances of about gesture of that same person, use that for testing. And the next of the rest of the 90 instances of the other gestures, use that for testing. Right? So that is the third assignment. So you do this for, you can change how many do you take for training and how many do you take for testing. There's a cross validation fraction, right? So the one that I said is 50% data for training, 50% data for testing. But you can change that ratio. You can make the 80% for training, 20% for testing, or maybe you can make it 20% training, 80% testing, or whatever your choice. You look at that and see what happens. So that will be assignment 3. Assignment 4 will be a different setting. Instead of user dependent classification, you should do user independent classification, which means that you take, so there are how many? 37 users, right? Or 38, 36, something. 7, right? Okay, 37 users. So out of that, take 20 users. 20 users, all user about data, put it in training. And all users not about data, like other gestures, put it in training. And then use the rest of the 17 users for testing the entire data set. Right? So what does this say? This is user independent testing, because what you are doing is you are taking 20 users which are not related to the other 17. So you are taking 20 users and you are making a model, and the other 17 users who are coming in, they don't even require training data. They start doing gestures and you recognize them. Right? So that is the fourth assignment. And then the last assignment, depending on whether we have time or not, we will just, instead of using the what decision tree, SVM and neural network, we will use deep learning things. So maybe we'll write a code in Keras or Piano or whatever and give it to you, and you can use it to test out different deep learning architectures. So that will be the 5th assignment, depending upon whether we have time or not. Right? But at least we'll have 4. So now we will do this because there is a reason. The reason is that we are going a little bit off topic, but let's go. So the reason is that this gesture recognition is a very hot topic. Right? Why is it a very hot topic? There are many applications to it. For example, applications such as sign language recognition. That's what we are doing, right? Sign language recognition. Then activity recognition is another thing, whether you're walking or running. Right? Those are important in different domains. For example, if I am doing a health monitoring of a person, I want to see whether that person is physically active or not. Right? Obesity, let's say. I want to have an intervention for obesity. One of the things is that you should be physically active. Physically active doesn't mean that you have to exercise. It means that you have to just walk around, do stuff in your house or in the lawn or something like that. Right? So how do I monitor whether the person who is trying to use this intervention is following a regime on is following a routine or not, right? A fitness routine or not? So what I'll have to do is I'll have to pervasively monitor it in the free living condition of that person. So I have to monitor, not only monitor but detect when the person is doing a physical activity and what physical activity is that person doing. So those things I need to will require gesture recognition or activity recognition, and the work that you are doing is the similar thing. Now, why this distinction between user dependent and user independent? So this distinction is due to a usability argument. So usability argument means that if I have a user dependent setting, then every time I deploy an activity recognition or gesture recognition mechanism, I have to collect training data from that person. So if I have to collect training data from that person, then that means for 2 hours or 3 hours, I'll have to just tell that person what to do. And the person has to do that and also give me manual annotations. Right? So the person has to know that, okay, I'm walking now, let's walk for half an hour. So that is very, it's very disruptive. People won't want to use that system. Right? So if you don't want to use that system, then what we have to do is we have to do automated annotation. So automated annotation means or plug and play operation. They go side by side or hand in hand. So plug and play operation means you just put the sensor and it recognizes. Whatever you do, it recognizes. So we want that. We want plug and play. So whatever you do, it recognizes means it also automatically annotates the data. Right? So it will say that, okay, this portion of data is this activity. It will know. So in that scenario, we need user independence, because if we want to just start recognizing in a plug and play manner, we don't have training data from that person. So we need user independence. Now, if you look at video, video-based activity recognition systems, or if you look at video-based anything, any recognition system, those are typically user independent. So facial recognition. In Facebook, if you upload a picture, it recognizes faces. It didn't take training data from you. Right? Ideally, training data from you would mean that you would take your own picture and you would mark that, okay, this is my face. So it knows that, okay, this position is this face. So it has a supervised, you can then use supervised learning. But it doesn't do that, right? Facebook just looks at the data and figures out the face. So how does it do that? It's user independent. Doesn't matter, depend upon user. So how does it do that? The reason it can do it is that video data or image data has visual information, and visual information is very important. And it comes back to the feature extraction argument, that if we know the features that you should look for, it's very easy to tell the computer to extract that feature. So if it is an image data, we know, we can see faces, and we can say that okay, face looks like a round face, it has a nose, it has two eyes. We can tell all these things to the computer. So regardless of whether it's a person A or a person B, they will have one nose, two eyes, unless somebody broke their nose, right? So they'll have one nose, two eyes, 2 ears, right? They'll have we know what to look for. So it's very easy to tell a computing system to look for that, and this is irrespective of any person. So this is truly user independent. So that's why, since you have the visual modality, it's very easy if you have video. But then it's not pervasive. For example, I cannot. So let's say a person is walking around and is doing gestures. So a person who is deaf and hard of hearing, he is doing ASL gestures, and I want to do continuous recognition. I cannot run with the camera in front of him, right? So I don't have the visual modality in practice. So what do I have? I have these sensors you can wear on the wrist, right? Or you can, some people also have, so there are some work which has near infrared sensors as a necklace. Not near, sorry, not infrared, no, not, it is the, what is it called, the sensor? Leap motion. Leap motion, you have heard about it? Leap motion sensors? Right? No? That's and this is boring, that's why I'm indulging in that discussion. I'll come to that, we'll discuss that as well. This type of sensors, these are infrared sensors actually. To chat. No, this motion. Anyways, there is a paper in Percom this year that does leap motion. So leap motion sensors, they can sense your hands, right? So what they did was, okay, you wear this leap motion sensor, and then your hands are extended from your body, right? So if you wear it as a necklace, then you can see. So if you make any gestures like this or like about gesture, the leap motion sensor can get all visual information. So that is one way. Or you wear a camera on your necklace as a necklace. Right? So those are different ways to obtain visual modality on your hands. But then the problem is, if you wear it as a necklace, we tried to do that. Remember, do you have the mother and father both in your ASL repository?
Just father.
Only father.
Only father. Father was what? This, right? And mother is this. So this work, I mean the newest work that came out, which is using this leap motion sensors to recognize gestures. This work very conveniently used mother. in their database, and then they removed father from the database. Why? Because mother is this, lip motion can capture. Father is this, the hand is gone in lip motion sensors. You don't even get the hand. So you don't even know whether what gesture you are doing. Right. So that won't be the problem if you have wristbands. If you have wristbands, wherever your hand goes, you have data. Right? But the problem with wristbands is there is no visual information. There is no visual information. The visual modality is totally lacking. So if the visual modality is lacking, as you have seen, can you, by looking at the data, can you argue that this has some features, hand movement features? It's extremely difficult task as you are being faced with. Right? You yourself are understanding that just looking at the data, you don't understand anything. You don't know what is due to the hand movement and what and which type of movement results in which type of signals. You don't know. Right? So it's extremely difficult. So you are facing the challenge now. So that is why using these accelerometers, user independent, you cannot do. It's very difficult to do user independent analysis. So I want you to face that disappointment. Share that disappointment with me. Right? So you'll be disappointed in assignment 4. Now there is hope. So the hope is that in CNN does what? CNN extracts all sorts of features, all possible features from visual modality, right? So can we have something similar in time domain? Just the one-dimensional these IMU sensors. Can we have those some sort of such a technique? Can we have such a technique? Right? Turns out that and we came up with one. You might be able to. So now if you look at one-dimensional time series, what kind of features can you extract? Linear features. What kind of linear features can you extract? You say A50, DWT, all those are linear features. Right? Peak detection, peaks are not linear features. Peak detection or indices and indices of peaks and the values of peaks are not linear. So you cannot generate. If you say if there is a technique to generate linear features from signals, then you cannot generate peak detectors. You cannot use peak detectors. But what you can do is, if you have used DWT in your project 2 or assignment 2, whatever you call it, you will see that certain coefficients of DWT enhances peaks. So if you use those coefficients, then what you can do is you can have a very sparse vector with just the peak point as a very high value. Right? So in that way you can do peak detection. So can we generate those type of all such type of features without handpicking, right, in a deep neural network setting? Can we do that? Turns out you can. How many of you know about Gaussian filters? You know, right? So Gaussian filtering is what? You have a Gaussian wave, and you just convolve the Gaussian with the signal. So what is the advantage of having Gaussian filters? The advantage is that you can smooth the signal at different levels. Not only smoothing, you can stretch the signal, you can compress the signal, you can subsample the signal. Right? So now this Gaussian filtering is what? Is a convolution operation. Right? So what comes to your mind? What should come to your mind? Maybe CNNs. Maybe CNNs with a certain type of weight functions can give us Gaussian, all sorts of Gaussian convolutions. Right? So FFT we can simulate using Gaussian convolutions. DWT can also be done using a specific type of Gaussian convolution. So instead of restricting us to FFT and DWT, why not check all possible types of Gaussian convolutions? Right? We can do that. So that is one way. So instead of using CNN, we use CNN, but in a different way. We formulate CNN in a different way, so that the weights are almost Gaussian. Right? That is one way. Now the other thing is distance. How do we compare? In image domain, how do we compare? Mostly Euclidean, right? Which we see that a pixel matches, then that's good. So Euclidean distance, and we are done. Now, do we need? Will we need any other type of distance? If any other type of distance other than Euclidean in the image based classification or any image based classification application? Do we need? Where?
If the background might change, but not the focus area.
No, then you can crop. Focus area you can crop. You can still use Euclidean. You can do object recognition. Yeah, after object recognition. But will you need anything other than Euclidean? So how many of you are familiar with IoT, Internet of Things? So what is IoT? Almost everybody is aware. What is IoT?
They're actually sensors. Basically, they're sensors.
No, IoT is not sensor. IoT is a mechanism. But yes, it uses a lot of sensors.
Everything is connected through internet.
Everything is connected to internet. So what is the use? By the way, that is IoET. Internet of everything. So that is also a somewhat controversial. Not controversial. Like because we as researchers, we need to get money, right? So if we need to get money, we need to invent new things. Because all these people who are giving you money won't give you money to redo or reinvent old things. So you have to invent new things. Now, how many new things are there in this world? Not many. So you have to forcefully invent new things. So what you do is you forcefully invent terms. So like IoT, Internet of Things, he said everything. There is a separate term called IoET, Internet of Everything. Then there are some terms called IOMT, Internet of Medical Things. Just as if just things is not enough. So there are all these terms, right? So well, regardless, that's not important. But if you think of IoT, what is a typical IoT application? Traffic monitoring, right? Traffic monitoring is a typical IoT application. Or let's not say traffic monitoring. No. Have you heard about Smart Investigator? Smart Investigator application? Not yet. So what it does is that it is a application that connects all cameras from different smartphones, not only smartphones, but security cameras, maybe these cameras, right? Or the cameras on top of traffic lights. Right? It attempts to connect all of them. So everybody has a IP address, and you connect all of them. Then what do you do with the connection? So what you do is you take images. So now let's say a person goes missing, and there is a police report that a person is missing. So what do? You collect all this. So let's say you give an initial location. So the person, somebody comes in and reports to the police, maybe Tempe police. So Tempe police says, okay, all cameras in Tempe, all mobile phones which have been in Tempe at some point of time, all security cameras, all classroom cameras, give me images. Now it asks the person who reported, okay, give me a sample image of that person, whoever is missing. So I will try to match. I'll try to match all of them, and we'll create a timeline of the person. Timeline means where was this person last seen. That will help in investigation. Now there is a huge problem in doing so. Now these images were captured with different cameras having different camera parameters. Right? Camera parameters means not just angle and and so, not just angle and zoom, right? But with different apertures, with different focuses, with different resolution, and you are given a picture that has been taken by another camera with different resolution, different camera parameters. It's an extremely difficult task to match that image that you gave me to images taken by different cameras. Why it's an extremely difficult task? Because you cannot do Euclidean distance matching. Because one pixel taken by one camera will not correspond to the same pixel taken by another camera. So you will have to do something called image registration, which means you have to match those two pixel by pixel, images pixel by pixel. Right? So if you want to do image registration, it's a very problematic task. So in that case, the Euclidean distance will not work. Why won't it work? Because now in order to match this image with another image taken by another computer or another camera, you have to stretch, you have to compress, you have to subsample, do all those things. That Euclidean distance doesn't do. Right? So if that is the case, a CNN can also will not work. It will not be able to compare. So the challenge here is that you want not only convolution features, but you want to also replicate distances that are non-Euclidean. Same for your gestures. So for your gestures, what you will see is that let's say the about gesture. Right? This is the about gesture, and I am drawing a hypothetical. I'm drawing a hypothetical pattern. So let's say this is the initial, and about gesture as something like this, right? And this is the data of one person. Then you see the data of another person is like this. Same about gesture. Then another person is this. Right? So, but this is the same pattern. How do you match these patterns? Euclidean distance won't work, not even correlation. So you have to do something. You have to squeeze this, match it, or extend this, match it, right? Or you can also have patterns like this. What is this? This is some noise. So what you have to do is you have to match these, then match these points. So maybe it's just shifted. So this won't be captured by Euclidean distance. Do you know what this type of distances can be captured with? This type of similarities? Have you heard about DTW, not DWT? This dynamic time warping. Have you heard about this? This is a new type of distance. It's a nonlinear distance measure, not like Euclidean, not sum of squares. This is a nonlinear distance measure. This cannot be replicated by CNNs or any neural network. It cannot be replicated. So when you go to non-visual domain, these are the problems. That's why it is very difficult to have user-independent settings. Right? So first of all, you don't have visual information, so you don't know what to look for. And you don't have a CNN-like architecture that extracts everything. Right? And second, you do not have any methodology to measure nonlinear distances, like DTW. You don't. So that's why user independent is a big problem. So when you do assignment 4, or you can start thinking about now, you might choose to use DTW. You are not required to, but maybe you can look into it. DTW has some feature, as a specific feature you can use. or maybe when you are trying to use a support vector machine, instead of a Euclidean loss function, you use a DTW loss function, something like that. But it's not mandatory. If you are interested, you can do it. And don't expect extra credit also. No, actually you can expect extra credit. So if you do DTW, maybe I will give you some extra credit, right? But you are not required. So you won't be penalized if you don't do DTW. Okay, so enough of this assignment 2. So you submit on Friday, and I'll post assignment 3 today, and you can work on it, and maybe I will see when you can submit it. Okay. So do you have any questions? So let's discuss association rule mining. So last time what we did was we saw that rule mining is a complex task, because if we have a set of items, then there can be infinite number of, there can be exponential number of rules, right? So we cannot explore all the rules. So in order to generate meaningful rules, we need to reduce the search space. Now how will we reduce the search space? There are certain methods and techniques, and these are based on certain overall knowledge of the system. So what is the knowledge? We said that, okay, there is this rule that we saw, that the observation is that the support, so we use support and confidence, right? Support means how many times a particular item set has occurred, and confidence means given X has occurred, how many times Y occurs. That is the confidence in that rule, right? So we say that this support and confidence are actually decoupled. We can decouple them. So if we just select an item set, then we can generate a large number of rules, and all those rules will have the same support, but different confidence. So what we can do is we can first look at support and then look at confidence. So what we do, we generate all the rules and all the item sets, and we only focus on frequent item sets. Frequent means the item sets that have a support greater than some minimum threshold. And then we evaluate confidence of the rules generated on them, and only take the good confident rules, just take those. That was our approach. But then we saw that even that has exponential complexity, because even if we try to fix one item set and then generate all the rules from that item set, that is exponential. And then the frequent item set generation rule that we will use, that also becomes exponential, because we saw that if we generate item set generation itself gives us an exponentially large lattice. Right? So we have to somehow reduce that item set lattice. So how do I reduce it? Not I. How do they reduce it? So they use something called an a priori principle. So the a priori principle is actually very interesting. So what they are saying is that if an item set is frequent, right, then all its subsets should be frequent. Why? Because if an item set is frequent, then every time we find that item set, we will always find its subsets. So it's always at least as frequent as the superset. Right? And we can also find out occurrences of the subsets when the superset has not occurred. Right? So subsets are always more frequent than the superset. So that is the a priori principle, and it's also known as the anti-monotone property of support. So we can use this a priori principle in a few ways. So first way is the top-down approach. So we start from a big item set and then look at each of their subsets. Right? So from a top-down approach, what do? we say that okay, if a big item set is popular, right, then we don't need to or has a big support, then we don't need to look at the subsets. We don't need to compute the support of the subsets. We know all the supports will be frequent. We know that. That is one way. The other way is from a bottom-up approach. So bottom-up approach means you start from individual items and then create item sets. So if you do that, then what you can do is that if you say that a particular item set has a support less than minimum support, then don't look at any item set that is generated as a superset of that subset. Then don't do, just delete. Because we know that any superset will have lesser support. And we don't need to look at it. So these two are the ways that we can use the a priori principle. Okay? And based on that, the a priori algorithm is developed. So this is what, just a pictorial representation of what we said. So this is, although this is the top-down approach. No, although it is written like a top-down here, but I called it bottom-up. So just reverse the letters in your mind. Right? So let's say this is the bottom-up approach. So you are going from null, and then you are looking at items, and then you say that okay, this is a very oh no, this was bottom-up approach. Well, okay, let's look at this. So let's say this is the bottom-up approach, right? So you look at small items. You made you saw an item set that is found to be infrequent. So whatever supersets are generated, just delete that part of the lattice. You don't need to look at it. On the other hand, if you take a top-down, I got confused. But anyways, if you start from bigger item sets, yes, top-down, bigger item sets, and go into smaller subsets, then you see that this smaller subset is a frequent item set. You don't have to go and compute the support of the rest. You just stop here and say that this is a frequent item set. Right? So that way, there are two ways of applying this a priori principle. So they have shown an example, and they say that okay, if I apply this, then it's drastically reduced. The number of items for which I have to compute support is drastically reduced. But that doesn't solve the problem. I figure out the frequent item sets, fine. But from there, if I generate rules, that is going to also increase, become exponential. So that also doesn't solve the problem. But even before that, there are problems with the a priori algorithm. So let's start from here and see what are the problems with the a priori algorithm. Right? So let's start from here. So what does the a priori algorithm say? So let k be equal to 1. Generate the frequent item sets of length 1. So how will you do that? So you generate all possible item sets of length 1, calculate their support, and just take the frequent ones. From the frequent item sets, generate length k plus 1 candidate item sets from length k frequent item sets. So which means that you take one item, length 1, which is frequent. If it is not frequent, delete it. But if it is frequent, you take that item set and you generate the plus 1 item set for that. So how do you generate plus 1 item set? What?
Combine it with the other.
Exactly, combine it with the others. Right? So if C is, so A, B, C, D, so we are going from null and then increasing. So A, B, C, D, E, F, let's say. So if C was popular or had a huge support, then what will you do? You will generate the A, C, B, C, D, C, those are item sets, second level item sets, right? So now count the support of each candidate by scanning the database. Right? So now you find out the support of the k plus 1 item sets. Find out the frequent ones, delete all the infrequent ones, and then repeat the process for all the frequent ones. So that is the a priori algorithm. So the algorithm initially makes a single pass over the data to determine support of each item. And this we already know. So what is this? The different steps are just listed here. We already know that. So the algorithm terminates when there are no frequent item sets generated. So if the frequent item set is null, then the algorithm stops. So the frequent item set generation part of a priori algorithm has two important features. First is a level-wise algorithm. Right? Level-wise algorithm means what? It first looks at one item set, then two item set, then three, then four, and so on. So it's a breadth first. It's almost like a breadth first search of the entire graph. So it's a level-wise algorithm, and then it employs a generate and test strategy. So you first generate the item sets, and then you test it. Now there are certain problems with this approach. This generate and test approach, as well as the combination of level-wise, being level-wise and generate and test. There are certain problems, not really problems, but inefficiencies. There are certain inefficiencies. So let's look at candidate generation. So the operation generates new k item set based on the frequent item sets found in previous iteration, and then you do candidate pruning, right? So candidate pruning means you look at the support and delete. Now there are certain properties. So what you need to do, it should avoid generating too many unnecessary candidates. So what is an unnecessary candidate? So let's read on. So candidate item set is unnecessary if at least one of its subsets is infrequent. Right? So what do we mean by one of its subsets being infrequent? So let's say I am generating ABC from AB. Right? I am generating ABC from AB. AB is frequent. Now I generate ABC from AB. Now I see that if I generate the subsets of ABC, then subset of ABC can be AC, BC, it can also be C. Right? Now what if C is infrequent? What if C was infrequent? What? Then ABC will be infrequent. So I am regenerating ABC, which should have been deleted. Right? So I should not generate ABC. So that is unnecessary item set generation. Why did I generate ABC? Because I know that ABC was frequent. AB was frequent, and C is another item. Not C is another item. I would actually generate ABC by combining AB and BC, right? By combining AB and BC, I will generate ABC. Because I only look at level 2 to generate level 3. I don't look at level 1.
Then BC would be formed, right? BC
What?
will be infrequent, right? In that case,
Yes. So that is another scenario, that maybe then BC is infrequent. So we will have to see that we do not generate this kind of sets, subsets. So that is unnecessary set generation, unnecessary item set generation. Then it must ensure that candidate set is complete. Right? Now that is another term, complete candidate set. So what is complete? So that is no frequent item sets are left out by the candidate generation procedure. So to ensure completeness, the set of candidate item sets must subsume the set of all frequent item sets. And so it should not leave out frequent item sets. Right. So let's say ABC and you found out that BC is frequent. Let's say C was frequent, and you. Okay, we'll see an example. But completeness means that you should not, the generation procedure shouldn't have a pruning step, right? Should not have a pruning step that eliminates frequent item sets. And then the final one is that it should not keep on regenerating same item sets. Right? So it should not generate same candidate item set more than once. For instance, they give an example. The candidate item set ABCD can be generated in many ways, right? By merging ABC with D, BD with AC, C with ABD, etc. Right? So you can generate ABC multiple times, ABCD multiple times. So you should not do that. Once you have generated ABCD and you have checked it, don't generate it again. So this is more of like a programmatic inefficiency. It's not like a theoretical inefficiency. Right? Theoretically, you can see that ABCD is the same thing, so don't ignore it. Right? Theoretically, it doesn't make sense. But when you try to write programs, then these kind of problems can come. So if you use the brute force method of generating item set, these problems will happen. You will have these problems. That you might end up generating the same item set again and again. So they are saying, okay, these are items, candidate generation of 3 items is all these items, right? So that is the brute force method. But then there is this fk minus 1 f1 method. That's the one that we are focusing. That only go level by level. Right? So an alternative method for candidate generation is to extend each frequent k minus item set with other frequent items only. Right? So the figure illustrates how 2 item sets can be augmented with a frequent item set such as bread to produce 3 item sets. So what they are saying is that these are frequent 2 item sets and these are frequent 1 item sets. How can you generate the candidate? So that's pretty easy. So beer, if you see that these are frequent items, beer, bread, diapers. So beer, diapers doesn't make any sense. But bread, beer, diapers, and so on, you can combine for only frequent item sets. Right? So these are not very, these are trivial things. So what the a priori procedure does is that it ensures completeness. A priori procedure ensures completeness as opposed to the brute force one. Right? Instead of brute force, if you use a priori, it will ensure completeness, and it will also ensure that it cannot ensure that items are not like you are not generating the same items over and over again. But no, it ensures just completeness. But it can have duplicate items. A priori algorithm have duplicate items. There can be many different ways of avoiding duplicate items. What you do is you keep the items in order, in some form of order. If you keep the items in some form of order and then you go according to the order. Right? So they are proposing lexicographical order. Or you can choose any other order. You can assign some numbers to each of the items and only combine based on the order. So those are some tweaks that you can do to make it better, more efficient, the priori algorithm. So then they show some examples. So there is another method, sorry. Fk minus 1, Fk minus 1 method. So this method merges a pair of frequent k minus item sets only if the first k minus 2 item sets are identical. So what is the difference between fk minus 1, fk minus 1 and fk minus 1, f1? What? Different?
One is just going like one layer down, the other is just going like 2 layers down.
One computation
No,
is
two.
within one layer and the other computation is across the layer.
Yeah, so this one, the first one is saying that okay, you do fk minus 1 with the first and go to fk, right? So which means that if you are at level 5, you go back to level 1 and try to add items there and generate candidates. The other method, fk minus 1, fk minus 1, that is different. That says that okay, you don't need to go back to layer 1. You stay in that layer, k minus 1 layer. Now you will merge two k minus 1 item sets if their k minus 2 item sets are the same. To understand what is happening here. So ABC and DBC, right? Now ABC and BCD, let's say. ABC. Now let's say ABC and ABD. ABC and ABD. So their k minus 2 are the same, AB, AB. So you can merge them and make a item set called ABCD. Right? So that is what they are saying. So don't look at the first layer, but just look at the layer itself. So here they are saying frequent 2 item set, frequent 2 item set. Which ones can you do? So the item sets 1 should be the same, right? K minus 2 should be same. So beer diapers, is no point in merging them. Then bread diapers, no point in merging them.
They're both the same.
Then beer diapers, bread diapers, right? Beer diapers, bread diapers. The one is beer and bread, so those are different. So you cannot merge them. Then what can you merge? Bread diapers, bread milk. Yes, you can merge bread diapers, bread milk, right? Because the k minus 2, which is 1, that is same, bread. So you merge them and you get bread diapers milk. So from here you get only one candidate. Whereas the other one, you get so many candidates. So fk minus 1, fk minus 1 might result in fewer candidates, fewer frequent candidates. It might result in fewer. So that is one trick that you can use for a priori algorithm. So that is what they are explaining, and we have already explained it. So no need to go and explain it again. Then the next step is you have to do the support counting, and you have to figure out the support. Once you have generated the frequent item set, you have to count support. Now there are many different ways. One way is to just go to the database and start matching item sets. Right? Start matching item sets and count. That might be a bit complex, right? So they propose a lot of algorithms. Now again, these are not very and nothing out of the ordinary that the book says. So I will skip these support counting and how to support, how to compute the support and all that. We'll talk about rule generation, but should I start it now? Okay, let's start because it's just 7 minutes. 7 minutes. We can look at the theory. Okay, that's good. So let's talk about rule generation. So once you have all the frequent item sets and all that using a priori algorithm, you have done it fine. Now you have to generate rules from those item sets. Now rule generation itself is exponential, right? On the number of items in the item set. So how do you reduce it? Now there is a theorem. So they are saying that unlike support measure, confidence does not have any monotone property. Monotone property means we cannot use an a priori principle for confidence. We cannot say that if a superset has less than minimum or higher than min sub, then all these subsets should be higher. We cannot say that those kind of properties. But for confidence we can say something. So this is a theorem. If a rule x goes to x implies y, x does not satisfy the confidence threshold. X itself is not satisfying the confidence threshold. And then any rule x prime y minus x prime, where x prime is a subset of x, must not satisfy the confidence threshold as well. No, why? Right. So again, let's reiterate that. So x goes to y. Now x implies y. Does not x implies y minus x actually. That's y. Okay, we'll talk about this next class. Let's stop here. Unless you have any questions. Wait, he has a question. You cannot go early. Yes.
So actually when users buy products, they buy like 2 to 3 together. We can take those as data sets instead of creating something from scratch. Those will be the ones that will be frequently bought, right?
No, so that is where we are trying to figure out rules, right? So those rules are not yet there. So those are item sets. Buying together is item sets. That is what we are trying to do. We are trying to figure out rules. So you have to figure out rules that have high support and high confidence.
We can take the user's data and then find like.
But users don't have rules. They have item sets. They don't have rules. Right? They have to generate rules. Any other questions you have? Okay. So next class we'll finish this a priori algorithm. Then we'll go into recommendation systems. Right? We'll talk about DeepMind. So do a little bit of study on Markov decision process if you can. If you have some time, just try to see what are Markov decision processes. So we'll talk about reinforcement learning next. And those are not in your exam. So you can relax.